All right. So in this class, we'll learn what are some of the functional tools that are available for us, and a lot of these functional tools are very Python heavy. Okay, which what it means is you don't need those for data science, but you may need those for machine learning engineering. Okay, ML engineering when you work on that section, so you may need. So we will circle back for a lot of other functions, but for now whatever are necessary, only those we will learn. So I've imported functools from functools. Okay, this also I have imported, and from functools import partial comma LRU cache. So these are two important ones for us. Okay, so we will learn this first. Now partial is nothing but in your high school or maybe your PUC, you must have learnt about partial functions. Okay, now partial function is nothing but in very simple terms. So one is a partial function, the other one is called as total function. Now total function is a function, if you notice here, x and y you have. Okay, x and y are sets. What you see here are x and y, which are sets. A function is said to be total function if one all the elements of x have some mapping in elements of y. Okay, this is called a total function. And a partial function is a function wherein which some elements of set x have, not all, some. Okay, here it is all, here it is only some elements of x have mapping with the elements of y. Okay, and the whatever the elements of x that don't have mapping, they will accept those mappings from another function. Okay, so that's why they are called as partial functions. Okay, if you want you can go through in-depth theory, but theory is not our concern. um, we will see how to implement those partial functions in our um, studies. So let's just say, let me define a function f. Okay, and this f I want to have three different elements along with the x. I will come back to you what to tell you what is that x. Okay, let's just say, even okay, let the function creation be there. Let's just say you want to access, if you're doing a data analysis, you are trying to find how well your target variable. This I'll again explain. No, if you are not understanding, don't worry, but just for the sake of explaining, let's just say there is a target variable y which is dependent on your multiple variables x, mx1. Okay, actually it is m1 x1 m2 x2. This I'll explain. Okay, m3 x3. What I'm trying to show here is, let y be, okay, income of certain person, and his income is dependent on something called m1 x1 m1. Don't worry about m1s. Okay, just worry about x2s and x3s and x1s. So x1 be his age. Okay, because he with age he'll have energy to do work, right? So with his knowledge. Okay, knowledge and skills are required to earn. Okay, and let's just say, um, his age, his knowledge, and type of work he does. Okay, his type of work also is very important. So let's just say these are three factors. Using these three factors, I'm trying to determine income y, sorry. Okay, and these are my x variables, x1, x2, x3. Now irrespective of what type of relationship they exhibit, here I'm assuming they are linear relationship. I will again explain you what is linear, non-linear, everything in data science, but for data analysis, for now you just understand that this is the equation of a straight line. You know, in your school you must have learned y is equal to mx plus c, or if not y is equal to mx plus b, or if not some variation of this equation saying theta 1 or theta 2, something like that. So if you recall,
Yes, yes.
this is a equation of a straight line, and here also it is a equation of straight line but dependent on multiple factors. That is why we have m1 x3, okay, m3 x3, m2 x2, m1 x1. So it's a combination, it's a linear equation only, but a combination of multiple variables. Okay, so the concept what I'm trying to tell you is, even though you can determine the income on these three things, there will always be some applicable error that you can never mitigate. Okay, so this is the assumption. Okay, this is not only assumption, it is true also in reality. If you want to predict income 100%, that is not possible. Maybe it is possible as 99.99%, but that 0.01% of error will always be available. Okay, will always be there. Hence we add a error term called c. Okay, so this is the overall explanation of how you try to fit various various parameters to determine income. Likewise, now coming back to our equation here, x I'm assuming as some error that will exist in a function. Okay, whatever the function you take, you try to map in the from the real world, it will always have some sort of x as the error term. That error term I'm taking as x. Now with this simple function I'm trying to return, let's just say some 1000 into a I have to type. Okay, 1000, this is a, what type of equation is this?
Is this an kind of activation function that is used in the deep learning? Like,
No, activation functions are different. We will come to that. Okay, we will come to that. For now, this you just assume as this is some function where our assumption is, in order to determine this income, let me write realistic values. His age has impact on his income, such that whatever his age is, let's just say his age is 30 years, he will earn 1.5 times the 30. So his package is 45. That's the assumption. Okay, just an example. That's what I'm saying. If his age is 20, he will earn 20 into 1.5 times. If his age is 10, okay, again, nobody has a 10-year-old, but just assume that this is applicable, this equation is applicable for people above the age of 21 and up until 55 or 60, whatever the age is. So my assumption is, the assumption I'm making is income a, which is my age, I'm saying 1.5 times his age he has to earn. Okay, that is, it could be that. Or I'm saying, based on his knowledge, let's just say he has knowledge, huge knowledge, he is an expert level knowledge, whatever, although you can't measure the knowledge, but I'm just saying, based on his sat scores or whatever the scores or other exam scores, assume that he has to get two times that score value. Or based on the type of work, each work will have certain applicable uh, salary range. For example, doctors earn, their minimum salary is 50K, starts from 50K, goes up to 5 lakhs per month, or 10 lakhs per month. Okay, so that way their salary, that is their salary range. Whereas you compare that with somebody else like a civil engineer, that is not the range, right? But for assumption purposes, just assume that they have to earn 10 times their type of work. Okay, that is my assumption. Okay, don't worry about these values, don't worry about abcd, don't worry about that x. All I'm trying to teach you is how a partial function works. Okay, pay attention to that. Don't pay attention much to what these things mean at the moment. So if you are I'm returning that error value, so this is my one function. Okay, now let's just say I have a partial function I'm applying to that f. To that function I'm applying a partial function. Now partial function, by definition, we learned that not all values will have a mapping. Okay, not all values of x will have a mapping. Hence I'm gonna provide only two values, 1 comma 1. 1 comma 1, what I'm saying is, this value that you talked about age, I'm talking age, let me take this age as 21. Okay, for a person of 21 age and the person of knowledge, his, let's just say his knowledge, if you measure the knowledge expert level from 0 to, not 0, 1 to 5, I'm saying his age is less, knowledge level is 1, then this is my partial function. Okay, it cannot be calculated by, because c is still missing, right? That is the definition of partial function, right? Partial function will not have mapping from, for all the variables, you one thing will be missing. Now in order to calculate this partial function, I'll have to create another function. Okay, g, I'm assigning it to g. Now I'm going to calculate this g of, I'm slightly going to modify some values, 2 comma 3 I will give. Okay, and I'm specifying this error, 2 2 value I'm specifying here, and 3 value I'm specifying here. Now it seems his package should be just, let's give some unit. His package should be 56,000 per month, something like that. Don't worry about the units or results or whatever, but just assume, just pay attention to how partial functions in Python work. Partial function is nothing but a function which doesn't have complete mapping to another function. G is another function. Okay, another function wherein which 2 comma 3 values are provided. Now C mapping and X mapping are available to 2 comma 3. Hence you can calculate the entire value. So this function is taking from partial function. Okay, partial function f. Is this clear? Understood?
Yes, 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 yes.
Okay, so this you, if you had to do in mathematics, you had to write a lot of steps that you can google and brush your knowledge up on mathematics, but in Python we do it this way. Okay, cool. um, all right, so this is one thing. In functools you have lot other things, but we don't need those things. Okay, like wrapper, you have update wrapper, you have cmap to key, something like that. So we don't need all those. Most important things is these only. Partial function also you will rarely use, to be honest. But LRU cache is very important. I'm sure if you are a developer, you would have seen something called something like this. If you have seen some code written by senior developers, you would have seen this. Okay, um, okay, let's look at what this is. Now let's just say I have a simple Fibonacci series or a Fibonacci function. Okay, this we example also we have seen. For Fibonacci you need to specify the end value, otherwise it will go in infinite loop. And I'm saying if n is less than 2, then my Fibonacci is result is same as 2 only, because 1 plus sorry 0 plus 1, right? So sorry, first two numbers are 0 and 1, right? That's why I'm just gonna return n value. So I'm gonna write this as a recursive function, or I'm saying return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, now if I calculate fib of 10 numbers, I have the total sum as 55. Okay, so essentially what is happening is, so this function 10 times it will be called until these values become this, until these values come down to n less than 2. Okay, so first 10 will be taken, 10 minus 1 is 9, 9 plus 8 will be added. Okay, then again the same function will be called, then this condition will be checked, again this functions will be called and added. Okay, then the values will become 8 plus 7, right? Then that way, if it keeps on going for 10 numbers, again this n is 10 numbers, not 10 values. Okay, um, so what would it would look like is 1. Okay, let's start with 0, 0 comma 1. Okay, 1 comma 2. Okay, and then sum of those two is 3 comma what is that, 2 plus 2 plus 1, 5, correct? Is this correct? 0 plus 1, then 1 plus 2, then 2 plus 5, No, 2 plus, no, 3 plus 5, 8. One second, let me get the numbers only. Okay, so a comma x comma y, 0, 1, then 1, then 1, 2, 1 plus 1 is 2, then 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 13, right? And then 13 plus 8 is 21. Okay, so if you add the total sum, okay, so that is being um, total sum should exceed 55, but why is it giving 55? What are we telling here? If n is less than 2, return 2. Okay, let me calculate that first. If fib of 1 is 1, okay, fib of 0 is 0, fib of 3 is 2, which is your third element, third index element. Again, fib of 4 is 3, okay, fib of 5 is 5. So that means if you are getting, so my 10th value should be 55. Okay, fib of 6 we already have 6, 7, 8. Fib of 9, let's look at fib of 9, 34. Okay, now my next value should be 55. That is what it is written. Okay, that is my fifth value. So this is my 10th value. That is what is being written. Anyway, now if you notice something, the same function is being called again and again. The sum of previous two numbers is being added again and again. Okay, so if I pass some big value for n, most there is a huge repetition of calling of functions, and computation time will increase. Okay, in order to mitigate that, we pass something called LRU cache. Okay, LRU cache is nothing but least recently used. Okay, LRU stands for least recently used cache. What this does is it gets wrapped around a function wherein which you have a possibility of exceeding the time limit or memory limit. So recently used values are stored in that cache, and as you know, cache is very quick, and you can also specify a max value what you want to have as cache. Let's just say few kbs. For example, max size is by default 128 kb. If you specify 128 here, or even 256 for that matter, 256 kbs of cache is reserved for your function. Let's just say you have written a function wherein which that is taking huge computation time, and there is a possibility that the repeated calculations are being happening. Okay, in that case, if you wrap it up, if you decorate that function with LRU cache, okay, so that cache values that it has stored, those will be used for computation. Okay, so if I do this, okay, it will still give me the same result, but now the thing is I can do, okay, it's taking a little time. Okay, maximum depth increased, let me see, depends on my memory value also, still increased. Okay, maybe 1000, yeah, okay, 1000, such big number has been generated. Okay, so it kind of maybe Fibonacci series is kind of exponential in nature. It keeps on, the maybe the curve goes something like this. Okay, anyway, so now you see the calculation, the difference is 256 bytes of memory was reserved in order to store these numbers for calculation, and hence the calculation of these numbers will be efficient. Okay, that is why you use LRU cache. Basically, LRU cache is used for dynamic programming as well as recursive functions, where if you notice that there is a recursive, if there is any expensive function, okay, um, if there is any expensive function that which needs your attention, which is taking too much time in your script, just wrap it around using LRO cache. You just import it from functools and wrap it around and reserve some memory for it, maybe 512 or 1224 something. Here I specified 258, that's why it got specified. Now I'm gonna increase one more number, let's see. Okay, still ran out. Okay, anyway, fine. So but you can reserve some memory. Here I have reserved 1 megabyte. You can reserve some memory as well. If you don't reserve anything, 128 will be reserved by default, and you can reduce the time of computation for that particular function in your code. Is that clear?
Yes, Sadi.
Okay, all right. The next thing is map reduce filter. Okay, I will take.
So,
Mhm. Yeah,
okay, I mean, this LRU cache is a kind of decorator, eh?
yeah,
Is it?
yeah. It's a decorator.
No?
Hmm.
Uh-huh. Okay. Okay. Yes. ठीक है, ठीक.
Decorators are also functions. Generators are also functions. Okay,
Okay. Okay.
decorate is enhancing the functionality of this. Okay,
Yes.
uh,
Yes. Yes.
by
Got it.
speeding up the storing some values and doing the computation in a quick way. For 1,000 values, you could see it generated almost
Mm-hmm.
like
And
instantly.
that is in a fraction of seconds.
Yeah,
Yeah.
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 So
Okay.
that's what.
Okay.
So that
Thanks.
is why we use. Okay,
Okay.
the
Okay. Thank you.
next thing is map reduce filter. This I would say are quite important. You will see these being used in your data analysis multiple times. Okay, so from functools, import reduce, comma filter. Map is not available because map is already available as outside functools. Okay, filter is also not available. Anyway, from functools, import reduce. Okay, to reduce, I will explain this with an example. Let's just say you have a function, okay, that returns factorial. Factorial is nothing but your, if you do a factorial of this we already saw above also, factorial of 5 is 1 into 2 into 3 into 3 into 4 into 5, right? That is equal to 120. So this is your factorial. This is represented as 5 factorial, right? This is what this is. Now I'm writing a very simple function, but here what I'm gonna not gonna write the complex logic that is there. Instead I will say return reduce reduced value. I'm writing a lambda. In lambda I'm gonna take two values, okay, and after taking two values, all I'm saying is just multiply them, because that is what we are doing in the factorial, right? Multiply them in the range of, start from 1, because 0 factorial is 1 and we don't use 0. Use n plus 1. Okay, so this is my very simplest factorial function. What I'm saying is, in a range of 1 to whatever the value, index value, if it's 4, you have to multiply till 5, because the index starts from 0, 0 comma 1 comma 2 comma 3 comma 4. So if I'm gonna talk about 4 factorial, this is already my fifth element. That's why 1 plus 1, n plus 1 here. Okay. So in range of 1 comma n plus 1, I'm just saying just multiply these two numbers. Okay, and reduce the value. Give me the final value. Reduce is used to obtain the final value. Now if I type fact of, let's just say 5 factorial to start with, and I will also type fact of, let's just say 10. You see, so basically reduce, even if you don't reduce, you will get the answer. You can use some other thing here, you will get the answer. But reduce, the speciality of reduce is it reduces the entire computation into a final value. You don't have to worry about the complete values it gives, but just the final value. So the use of reduce is, okay, cumulatively it will compute. Don't, that is not our thing. So reduces the iterable to a single value. Okay, that is its use. If you want to obtain final value, you just add reduce here. Okay, let me show you something else. Okay, not list, maybe. Okay, map, list of map. Missing one required argument b. Okay, one second. Where is the value of b? Why is it looking for value? Okay, okay, anyway, fine, maybe I will explain you again using a much simpler example. But for now, just understand reduce is used to reduce the entire computation into its final value. Okay. um, so that is the use of. Mhm. I'll
Why
explain. Yeah, yeah, go ahead.
why why are you use lambda?
Lambda is just an anonymous function. I'm trying to calculate by taking two variables. You can do it without lambda also. If you want to write this without reduce, without fact. Okay, let's just say I don't want this. Okay, I want to define the n value first. Okay, and now I'm saying reduce this for these many values. Okay, so you see, if you change the value of n here, you'll get fifth factorial. You don't need that function essentially. What you need is the lambda. Lambda is just an anonymous function. In that we are taking a comma v as variables and applying multiplication to those variables. You can write this using custom function also. If you write some function here and you need not call lambda, you can call that function instead. Okay, so lambda is just anonymous function here. Basically reduce takes a function, that's why we are using lambda, because we don't want to define a function. But you can use anything. You can write your custom function also here. If you type def add, take two numbers and add those numbers and return the sum, then lambda will reduce that to its final sum. Okay, final value. Okay, that is what the use of reduce is. Likewise, if I specify 10 again and reduce it, let's just say I want to. Okay, let me take this def of add. This is what you said, right? Def of add, and here return uh, a plus b. No, something like that. Okay, here I will take some marks. Okay, I'll have to pass arguments also. In the arguments, I will pass 2, comma 3, comma 4, comma 5, something like this. Okay. Okay, fine. So reduce expected 2 got 1. Reduce expected at least 2 arguments. Okay, function as well as you need a iterable, right? Function is your add itself. Okay, and you provide it to a iterable. Okay, fine. Here I will return only instead. Val is not defined. Return what is the use of n here? Okay. So basically I'll have to take a list. Okay, let me define list here. L is equal to, you notice the complexity increasing, right? So if you wanna execute the same thing, so here I will say for I in L, okay, you just return me the, okay, just return me I for the sake of simplicity. Okay, uh, int object is not callable. Where am I passing int object? At takes 0 position but 2 were given. Anyway, fine, don't worry about this example, but just see the increase in the complexity. If you want to replicate the same thing wherein which you want to return the final sum, you can write it, but without reduce. Without reduce also you can write it. If you want to write without reduce, it becomes easy. You just have to iterate over the list, add those numbers, and then return the sum. So basically, if I want to do that, you just have to define sum is equal to 0 for I in range of L. Sum is equal to sum plus I, right? And then finally, you return outside the for loop, you return sum. And your should be something like L is equal to 1 comma 2 comma 3 comma 4 comma 5. Okay, so if you call add, okay, so you have 15 because the sum of all these numbers is 15. If you want to test that, add another 6, call another, you got 21. So this way you can do it, okay, without reduce. But look at the complexity. So complexity will keep on increasing. Now this is add function, right? This is only my add function. Now if I want to return the product, I'll have to write another product code here, right? So the function differs. So that way, what reduce is doing is it's eliminating the use of this function. Instead it's defining anonymous function. All I have to do is just add a plus here. If I want to return the addition, all I have to do is just add a multiplication. If I want to reduce, I don't have to write two different functions. I don't have to write complex logics in order to return this. Okay, so that is where my reduce is coming. So here reduce is trying to simplify the return of the final value. If you want to return the final value, you can use a lambda function. No need to define these custom functions, and then you can use the reduce to get the final value. Is this clear? It's basically used to simplify your functions and return the final value. Likewise, we also have something called map. Okay, we will check what is map, and we will check what is, we'll look at what is your filter. Now this we already have, very similar thing we already have seen. Let's just say I have written a function called double, and all I'm trying to do is return n into 2. Whatever basically the number you pass, that has to be multiplied with some value. So L we already have defined 1 to 6. For this, I'm gonna take the result in a variable, and I'm gonna apply that function double to a list that I have already created. And if I now print list of res, you see what happened? Each number in this got applied with this condition. So n into 2 got multiplied, and the final result we obtained. Okay, but if I do list of res of double, so if we do list of res of double comma L, so you get map object, sorry, not res map, so you get the same result. So this is what it is. So based on this function, basically you can take a function, apply it to iterable, and you'll get the final result. That's what map is for. Map is for mapping a function to a iterable or a list, basically, or a sequence type. Is this clear? Map is straightforward.
Yes.
Reduce is also same. See, all these things will have more or less the same syntax. Okay, but the final result varies. That you need to know. And filter also is the same thing only. So filter works in a way that it we already have seen filter false, right? So it's the same exact way, but I will take the same example. Okay, so try to get a even number for n values, okay, and return to check if n mod 2 equals to 0. This is basically checking if n number that is passed is a even number or not. And I have a list here already. Okay, I can use a list L. So what I'm saying is filter is apply this is even function on that L and filter me the values, and if you filter you'll get a filter function, and for that filter function if you apply a list on top of that filter function, you will get 246. Wherever the numbers are divisible, you will get those values. But if I apply filter false here, okay, filter false was, if I apply filter underscore, what was that? Filter false, is it? Iter tools from, okay, fine, let me import that. Maybe from iter tools import filter false. Okay, filter false of this, you will get 135. So basically filter and filter false are opposite. This we already saw above as well, I think, but again just a repetition. So you take a function based on the condition, you check that condition on all the elements, and filter will give you the end result. The same thing if you apply for a map. If I apply map, see what happens if I apply the map here. See what happened? So it's giving you a selector. Selector means wherever it is false, wherever it is true, that it will give you. But if you don't want to write a condition, so the difference between these two is, here you are checking for a condition and hence filtering based on that condition. Here you are actually calculating the values. If you want to actually calculate the values based on certain criteria, certain operation, you use map. Or if you want to filter out the elements based on a condition, you use filter or filter false. Is this clear?
Yes. Sadiq, so L is defined for list, right?
L is a
Uh,
list. Yeah, that is what it is. 1 2 3 4 5 6. This one.
yes, yes.
Okay, I will write everywhere if you like.
No, no. Got it.
Okay, all right. So L is list there. This completes your functools. Is there any doubt in this?
No, no, it is clear.
Okay.